Hey everyone, and welcome to the Explainer. Today, we're diving into something that is literally flipping the script on how we view technology, AI and machine learning threat modeling. As we wire AI deeper and deeper into our systems, it turns out the old ways of securing them, they have to completely change. We're moving away from a world where we just protected static code to a world where we've got to protect context, behavior, and data. So, let's jump right in.
Let's kick things off by looking at two wildly different security failures. You know the big ChatGPT outage back in March 2023? Well, that actually wasn't some hyper-advanced AI attack. It was just a traditional software bug in an open-source library that ended up leaking user metadata. But then, contrast that with Microsoft's Tay chatbot from a few years earlier. Tay wasn't taken down by a simple code bug. No, it was taken down by adversarial poisoning. Users actively fed it garbage data to manipulate its learning loops and, well, make it produce incredibly offensive behavior. This perfectly highlights the real challenge here. We are fighting on two completely distinct fronts at the exact same time.
Now, a massive takeaway from our source material is this: AI and ML threat modeling should not replace conventional software threat modeling. It should extend it. We aren't just throwing away our established security foundations. I mean, a weakness in your identity management or your cloud configuration, that will still absolutely wreck your AI system. What we're doing today is building on top of those solid foundations to tackle the truly unique vulnerabilities that AI brings to the table.
Okay, let's look at our roadmap. First, expanding the attack surface. Second, the AI threat landscape. Third, choosing the right frameworks. Fourth, real-world AI attacks. And finally, the threat modeling process itself.
Right, starting off with Section 1, expanding the attack surface. We're moving from code to context.
We really need to completely shift our mindset here. You see, an AI system isn't just some static piece of compiled code sitting on a server. It's this massive, complex, socio-technical pipeline. On the left side of this comparison, you've got your traditional security boundaries, things like code paths, identities, and storage. But look at the AI boundaries on the right. They're fundamentally different. We're talking about training data, labels, human feedback, inference APIs. In traditional software, data is just the stuff the code processes. But in AI, the data literally dictates how the system behaves. The huge shift here is that data and model artifacts are now elevated to first-class security assets.
Just to make sure we're all operating from the exact same baseline, let's define AI/ML threat modeling. It's the structured analysis of how attackers, misuse, error, or dependency failure could compromise data-driven systems across their full life cycle, and what controls reduce that risk to an acceptable level. Notice that phrase right there, full life cycle, because you absolutely cannot just slap some security on the final API endpoint and call it a day. It doesn't work like that.
And because we're looking at that full life cycle, our list of assets to protect has totally exploded. We aren't just guarding a database anymore. Now we have to secure the raw training data, the labels provided by outside vendors, the feature pipelines, and the actual model weights themselves. And I really want to highlight that last point. In modern agentic settings, meaning AI that can actually go out and take actions on its own, things like model memory and tool execution credentials, those are incredibly high-value targets for any attacker. Moving right along to Section 2, the AI threat landscape. Let's look at these new vulnerabilities. All right, here are the life cycle spanning risks that are completely unique to AI. We've got poisoning, which is where attackers actively corrupt the training data. There's backdoors, where a model might look highly accurate on paper, but it actually has hidden triggers baked in that cause misbehavior. Evasion, which is all about tricking the model during live inference. And then we've got privacy and IP threats, things like model extraction, where they try to literally steal or replicate your proprietary models, or membership inference, which exposes the exact sensitive records the model was trained on. And keep in mind, the threat actors pulling these off aren't just your classic external hackers. We're talking about malicious end users, compromised labelers, and even third-party data contributors. It's a whole new ballgame. Which brings us to Section 3, choosing the right frameworks. We're looking at the hybrid approach. So our sources strongly suggest that the best working approach for an organization isn't to force your entire AI pipeline into one single rigid doctrine. Instead, it's a hybrid approach. You basically stack established frameworks together. For example, Stride is absolutely fantastic for nailing down your baseline architecture and API trust boundaries. Then you can layer Pasta right on top of that when you need to figure out concrete attacker behavior and real business impact. Now, if your model is touching sensitive personal data, you'll definitely want to bring in Linden to cover privacy flows, Octave is great for handling broader organizational risks, like third-party suppliers. And finally, MITRE ATT&CK combined with Atlas acts as this perfect overlay to map out specific adversarial tactics. Now, if digesting all of those frameworks just felt a little bit overwhelming, don't worry, I've got you. Here is a super clear, digestible takeaway for any team just starting out. The recommended beginner stack is Stride plus Pasta plus Atlas. This trio is incredibly powerful. It gives you broad system architecture coverage, realistic attacker abuse cases, and a totally up-to-date AI-specific tactical library. And the best part? It does all of that without absolutely crushing your engineering teams under a mountain of heavy process loads. Let's move into Section 4, Real-World AI Attacks. It's time to look at some high-stakes failures. $77 million. That is just a staggering number. According to published MITRE Atlas materials, that is exactly how much was stolen from the Shanghai Tax Authority by attackers. How did they do it? They used a fake video feed and some black market photos to completely bypass a machine learning-enabled liveness check for facial recognition. Crazy, right? But this brings up a truly critical question. Was this a failure of the algorithm or a failure of the system? Well, think about it. The algorithm might have been operating exactly as mathematically designed, given that spoofed input. But the system as a whole? It totally failed. This teaches us something huge. The surrounding business controls, the identity proofing workflows, the human fallback reviews, all of that matters just as much, if not more, than the isolated accuracy of the model itself. And we see these kinds of systemic issues popping up in other case studies, too. Bad nets completely prove that supply chain backdoors are a very real, very scary thing. Pre-trained models can pass every single accuracy test with flying colors, but still harbor these hidden sleeper agent triggers waiting for a specific attacker input. Then you look at the 2026 OpenClaw investigations. Those revealed that the moment you give AI models agentic capabilities, meaning the ability to interact with real-world tools, exposed control interfaces can lead straight to full host compromises and credential access. These attacks are actively evolving way beyond just generating bad content. We're talking about complete system takeover. All right, final stretch, Section 5, the threat modeling process. Let's put this into action. So here is the actual cadence. Step 1, set your scope and inventory those assets. Step 2, map out the full lifecycle and all the data flows. Step 3, enumerate the threats using Stride, plus those AI-specific prompts we talked about earlier. Step 4, score the risk based on likelihood and impact. And Step 5, mitigate and validate your top threats. See? Securing an AI model isn't some kind of black magic. It's a highly achievable, step-by-step evolution of the traditional software security workflows we already know. Now, the absolute most common failure mode for security teams is scoping their AI model way too narrowly. They usually just stare at the final inference API and ignore the rest. To avoid doing that, here is a super practical starter set of questions to ask during your modeling. Are public inputs being fed back into your training? What QA checks are actually catching adversarial labels? Are your imported pre-trained models digitally signed? Does your API leak these rich confidence scores that an attacker could just use to reverse engineer the model? And crucially, what external tools or credentials can your model actually reach out and touch? Okay, so once you find all these vulnerabilities, you have to prioritize them, right? This enterprise scoring method provides a brilliant, highly defensible way to separate things out for your engineering teams. Your risk score, which is just likelihood multiplied by highest impact, determines the absolute severity of the threat. But then your prioritization index divides that risk by the remediation effort. This tells you the actual execution order. Because look, a severe threat might take 6 months to fix, but a slightly less severe threat with a cheap, high-leverage fix, that might jump straight to the front of the queue because it drastically reduces your overall risk footprint right now. Bringing everything together, the crucial point is captured just perfectly in this quote summarizing all the real-world incidents we've looked at today. The damaging failure is usually at the boundary where model behavior meets system privilege. Honestly, hit the nail on the head. This is exactly where you need to spend the vast majority of your threat modeling time and energy. It is not just about what the AI model says, it's about what the surrounding system actually allows that model to do. Which leaves us with this final, somewhat provocative thought to take back to your own projects. Look at the AI pipelines your organization is building right now. If your model has the capability to observe sensitive data, remember past interactions, or execute real actions, what will an attacker make it do? Think about it. Thank you so much for joining me on this explainer. Keep learning, stay curious, and I'll catch you next time.